Okay, so now we're done with all the math. Now we get to talk qualitatively about a few wider topics in waves. So, for instance, what happens when two waves are present at the same place and the same time? So this general situation is called interference. Interference, right here. And because the wave equation is linear, for any two waves, say the first wave is y1, function of x and t, and the other wave is y2, function of x and t. For any two waves that satisfy the wave equation separately, their sum also must satisfy the wave equation. And so therefore their sum is a physically possible wave. Their sum, y1 xt plus y2 xt. The wave yxt that is composed of each of those, the addition of each of those. This linear combination property is an example of the principle of superposition, which is a very important property. Principle of superposition. It just basically means when waves overlap, the displacement at any point x and time t is equal to the sum of all of the displacements of the individual overlapping waves. And it doesn't have to just be two waves. So in general, it looks like what I just wrote down. The displacement, this function y, is a function that describes the displacement of any particle at time t and position x. It's equal to the sum of all of the overlapping waves, y2, x and t, plus yada yada yada. They don't all have to be, up at the same time. So if one wave happens to be like this, meaning displacement is here, let's say displacement of, let's say displacement of y1 at a given x and t that we're looking at is its full amplitude. Displacement of y2 could be the inverse, negative a. So let me do two different colors, might as well. So it could be negative a. So if y1 at the point that we're looking at happens to be like this, right, and it's a wave, at this point and time is a, well, we could have this other wave that's overlapping completely inversely, and its displacement is negative a at that same exact time and place. In which case, the resulting wave from the superposition of those two waves is no displacement, and therefore you get, if they are exactly inverse of each other, no wave. It's pretty interesting. So, this concept is another one of those, I keep saying this, but it's very true, that has implications way beyond just waves on a string, even beyond electromagnetic waves, and it has implications in quantum mechanics and beyond. So, it's worth remembering and hanging on to. If the waves add in such a way to completely cancel out or just diminish what the amplitude would be. So if this purple wave takes away from what the displacement of the yellow wave would have been, if they're in any way inverse in each other, even if not fully inverse in each other, then we call it destructive interference. Destructive interference. Because it is interference that is it's destructive to the would-be wave. And if you get two waves that are interfering in such a way that the amplitude or the displacement is increased, you would have maybe a wave like this, and we're looking at this point right here, and then you have another wave that maybe is like this, right? And at this point, its amplitude is greater. So then the total amplitude is this plus this, right? The purple plus the yellow. So it's this total amplitude. So it would be this addition of the two waves. That is called constructive interference. Or we would say that those two waves constructively interfere. Yeah, by the way, it doesn't have to be completely, at the same frequency. You can have different frequencies. So you can have one wave that's like this, and another wave that's like this, right? And if you happen to be looking at, so if this is your, oops, if this is your midpoint, we'll just declare, then at this point here, we have that minus that. That would be the total wave. And then over here, we have this little bit, but also we have this larger bit. And so you get this really interesting complex wave that isn't periodic anymore. Probably doesn't look anything like that, but yeah, so you get these little, really complex waveforms. And if you've played around with audio files, you can kind of see these complex waveforms as they, if you zoom way in, it's just processing all these different tones that are overlapping with your voice or the music. And so we'll talk about sound a little bit more in the next chapter, but that's a little way that waves interfere with each other.